Welcome to the video. My name is Priya. Let's continue to talk about organic chemistry as the previous video. So last time we heard that organic chemistry is the study of this carbon and its compounds with other elements. The reason why carbon needs to form compounds with other elements is because on its own it's not stable or it's not satisfied. It has only 4 electrons in its outermost shell, whereas to be stable for this carbon it needs 8. So to strive for stability, in a quest to find that stability, it tries to combine or share electrons with other elements, for example, hydrogen. So this carbon with its 4 electrons holds hands with these 4 hydrogens, and each of these hydrogens bring with them 1 electron each. So these bonds are 2 electrons each now, and so around this carbon there are 8 electrons which are going around. So 1 electron comes from hydrogen, the other electron comes from carbon. Now we also saw, what if a carbon which has 4 hands combines with another carbon which also has 4 hands? So are they able to join this one hand in the middle to form a stable compound? The answer is yes, and this is a remarkable capability of carbon to form bonds with each other, to form long chains. This is called catenation. So carbon and carbon together can hold hands. So this bond will have 1 electron belonging to this carbon and the other electron belonging to the other carbon. And the rest of them we can have hydrogen, or we can even have other carbons. So you can go on and on. You can make a long chain of so many carbons and the rest of them being hydrogens. Now the question arises, what happens if these 2 carbons, instead of just holding one hand, hold 2 hands, because they have total 4, right? Is that possible? Let's see. So if I have these 2 carbons and they each have 4 hands, so what if they share 4 electrons among each other? So these 2 electrons belonging to this carbon and these 2 electrons belonging to this carbon. So together they can form a double bond. The one that we saw here was a single bond, and now when they are sharing 2 hands with each other, or they are holding 2 hands with each other, we have a double bond. So what happens in a double bond? These 4 electrons are actually belonging to this carbon as well as this carbon. So what would you expect? These electrons are attracted to this carbon core as well as this carbon core. So these 2 carbons come closer to each other. You can also think about it this way. The more you share with your friends, the closer you get. So you can say that this double bond is actually shorter than a single bond. So this is a single bond. These 2 carbons are just holding one hand with each other, and these 2 carbons are holding 2 hands with each other. So there is more attraction of these electrons with this carbon core as well as this carbon nucleus. So this is about double bond and single bond. Carbon chains, which are open chains, which have only one hand of each carbon being shared between 2 carbons. That means we have a single bond. So this carbon is actually sharing with 2 different carbons, but with one carbon it is only holding one hand. These type of compounds are called alkanes. So you can remember it with an A in the middle. A means one, so it is a single bond. When you have 2 carbons holding 2 hands with each other, giving rise to a double bond and an open chain of this is called an alkene. So alkene is for a double bond, alkane is for a single bond. Now a very natural question, I also have it. What if this carbon holds 3 hands with the other carbon? So I have 4 hands for this carbon, right? And it's sharing 3 of those hands with the other one. So is that possible? This carbon with its 4 electrons and this carbon with its other 4 electrons. So they're essentially sharing these 6 electrons between each other, giving rise to a triple bond. Now what would you expect? Would this triple bond be shorter than this double bond or longer than this double bond? Now, as we saw last time, the more the 2 carbons share, the closer they get. Therefore, triple bond is shorter than double bond. So the length of this bond decreases. This is because the 2 carbons need to be closer to each other because they are sharing 6 electrons, and these electrons are being attracted by the nucleus of this carbon as well as this carbon. So we saw that the ones with single bond are called alkanes, the ones with double bond are called alkenes. So the ones with triple bonds are called alkynes. So A for single, E for double, and Y for triple. This is just a trick I used to use. Alkanes with single bond only holding one hand. This one hand is a strong hand, but it is much longer than this double bond. So this double bond, because they are sharing 2 hands, therefore it is shorter than the single one. And here, because they are holding 3 hands, therefore this is shorter than the alkene double bond. So now let's quickly do a recap as to what we learned in this particular video. We learned that carbon can make bonds with each other, called catenation. We learned that when it is a single bond, then it is called alkane. When it is a double bond, then it is called alkene. When it is a triple bond, it is called alkyne. A double bond is shorter than a single bond, and a triple bond is the shortest, so it is even shorter than this double bond. Now, one very natural question, since both of these carbons need 4 hands to share with each other, can't we just form 4 like this and be stable and happy? The answer, unfortunately, for carbon is no, because these 2 carbons will then get so close to each other, then their positively charged cores will repel each other. So getting too close such that these 2 positively charged cores start repelling each other, and therefore this bond is not stable, and therefore C, 4 times bond C, does not exist. So what we have is these 3 alkanes, alkenes, and alkynes. Thanks for listening to the video. Stay tuned.